In partnership with EU, the Secretariat of the Organization of the African, Caribbean and Pacific States has initiated the Intra-ACP Climate Services and Related Application Program ClimSA. The world is changing in great speed and the energy needs all around the planet are getting higher and higher. Modern societies require vast amounts of electricity to meet their needs, a necessity that in many cases has harmful environmental effects, both in developed and developing countries. Several actions point to the fact that a more climate-resilient economy and society must be built in each country, including measures aimed at reducing fuel consumption for energy production, providing emphasis on energy efficiency and conservation, as well as on power generation from renewable sources. Among all the forms of renewable energy, solar energy is one of the most attractive forms due to its universal availability. Photovoltaic systems are one of the most effective, efficient and sustainable ways to generate electricity with the use of solar energy. New technologies and detection methods make them not only an excellent solution to green energy production but also a cost-effective solution with amazing production potential. In combination with the Earth observation data and information, photovoltaic systems are capable to operate in every place of the planet in high levels with great efficiency. Photovoltaic solar cells are constructed from semiconducting materials, most commonly from silicon, and with the advances in photovoltaic technology their lifespan is extending and can reach up to 40 years. Their operation is closely linked to environmental conditions, such as clouds, dust and weather phenomena that could affect their performance, but access to scientific data and information that modern technologies provide, from Earth and space, can ensure their productive capacity through forecasting and monitoring. Moreover, solar energy potential is sensitive to various atmospheric parameters. Except of the impact of clouds and aerosols on solar energy, one critical issue for the operational energy planning and related policies is its estimation in real time. The fifth assessment report of the International Panel on Climate Change has highlighted a need for increasing the breadth of studies into the impact of clouds, aerosols and their feedback processes on climate change. Although, large photovoltaic installations have already built in places where solar insolation is high and cloud-free sky conditions prevail for the largest part of the year, many regions and countries all over the world have laid out specific technology roadmaps aiming at the integration of low-carbon energy technologies linked with the deployment of photovoltaic installations in the energy market, and they have set as main sustainable development goal by 2030, to ensure universal access to affordable, reliable, and modern energy services. Since energy production, transportation and consumption put considerable pressure on the environment, there is serious concern regarding the sustainability of energy consumption. Earth observation-based systems and relevant services already play an important role in the solar energy industry, as well as in human health-related emerging technologies, but there is still significant potential in increasing their efficiency and exploitation. Earth observation from space is already triggering services and applications that can deliver benefits throughout all the phases of energy production and supply. Their contribution ranges from identifying reservoirs and locations with solar energy potential, to controlling and monitoring of the distribution networks across every corner of the planet including Caribbean, Africa, and Pacific Ocean, while providing support to energy policy formulation and enforcement.